All right, my trig girls. We are on number 8. This is the last problem on your homework sheet for section 3-1. I am also going to have you guys, I think I'm giving these notes to Mallory for section 3-2. I'm going to give her the notes and the homework just to do the first couple of examples for 3-2 so we can finish 3-2 notes tomorrow. So I am going to start section 3-2 with you guys on this video. So get that stuff from Mallory, and that way we don't just waste a day for me being gone. So starting with number 8. I'm going to do part of this with you, and then I'll have you guys do like B and C by yourself. So they are giving us the graph of the function 5 over x, which is one of those boomerangy things. And really they're only giving us the one side of the boomerang. The other side would be down here. So we're only focusing on like the top right side. And we are trying to figure out how long this segment is. And the problem with doing this is that it's curved. We can't find the length of a segment that is curved. So we use things to approximate it to figure out how long it is. So if I went ahead and just took the endpoints, which are 1, 5, and 5, 1, and if I just took those two endpoints and I drew a straight line between them, and found the distance between those using the distance formula, that would give me some sort of distance, and we're gonna calculate that here in a second. But this is going to be a little bit longer of a distance than what that is even, right? Because that's a straight line and this is a curved line. So rather than doing this method and just finding one line, we can separate this into chunks, okay, and do the distance from here to this point, okay, and do the distance from here to this point, and do the distance from here to this point, and here to this point, and we would add all 4 of those up, and then that would give us an even better approximation, okay? So what we're going to do, let's do this first. Let's calculate, we have these endpoints here, 1, 5, and 5, 1, but they don't have labels for these pieces in here, and let's go ahead and figure out what those are. So this guy has an x-coordinate of 2, this guy has an x-coordinate of 3, and an x-coordinate of 4. That's where they are labeled at, and we have to figure out what the y-coordinate is on each of those. So we have the formula, and all we do is just plug that into the formula to figure out what that is. So this y-coordinate would be like 5 divided by 2, or you can say like 2.5. This one would be 5 divided by 3. We'll just go ahead and say 5 over 3. I don't usually like to convert thirds to decimals because we end up having to round. 5 divided by 4 is 1.25 as a decimal. Okay, so we have those points in there, and what we're going to do is we're going to just find some distances to see if we can approximate the length of that curve, okay? And again, this is all stuff that we will eventually learn how to do with calculus, but since we don't know calculus right now, we're just finding ways of approximating that, okay? So part A says approximate the length of the curve by finding the distance between the two endpoints as shown in the figure. So we're just doing these two things, and we're trying to find the length, okay? So the distance formula is this guy. It's the x2 minus x1 and y2 minus y1, okay? But I usually tell my geometry kids not to get bogged down with like the notation for x2, x1. Basically, that's just saying like in the x direction from 1 to 5, those are my x coordinates. How far are you going? And you're going a distance of 4, right? So this would be the square root of 4 squared, right? Plus, and then in the y direction, you're going from 5 to 1, which is technically like a -4, but when you end up squaring a negative number, it ends up being positive anyway, so we're just going to write it as 4 squared. So we have the square root of 4 squared, that's 16, 16, that's the square root of 32. So like 5 point something. Let me get that exact number. The square root of 32 is 5.66, let's say. 5.66 is the approximation for that distance. Now, that's just the distance from here to here, so we know that the distance of the curve, the length of the curve, is going to be slightly more than 5.66, okay? So there's how that works. B, I'm going to get you started on B, and then I'm going to let you go by yourself, okay? So B, it says approximate the length of the curve by finding the sum of the lengths, okay? So we're going to do the distance from here to here, figure out what that distance is, add that to this distance and this distance and this distance, okay? So if we do the first distance, we're going just from 1, 5 to 2, 2.5. So I'm going to do segment number 1. We can do segment number 2, segment number 3, segment number 4. Segment number 1 is the square root of, if I'm going from 1 to 2, that's a distance of 1, so 1 squared, plus if I'm going from 5 to 2.5, that's a distance of 2.5. Really, it's a negative 2.5, but again, I don't usually like to put negatives in there. So 1 squared is 1, 2.5 squared is 6.25, and so we have the square root of 7.25. And that is a distance or a length of we'll go 6.9. We'll go 2 decimal places. 2.69 is the length from here to here, okay? Now figure out all those other lengths and we'll see, this will give me a better approximation of what the distance is. Again, this number should end up being slightly larger than 5.66 because it's going to get me closer to what the actual is, okay? So finish that and then see what you can come up with part C. They're kind of asking you, we talked about it up here when we were talking about the rectangle thing. See what you can come up with part C, okay? Now, pause this, finish that problem, finish part C, and then I'm going to go down to section 3.2, and we'll get started on him real quick. So pause it, and then we'll come back to 3.2. So here we go. 3.2 is looking at graphs and finding what's called a limit, okay? And a limit, in the most basic terms I can explain it, is the y-coordinate where x coordinates poop out, okay? So where x coordinates, I'll say where x coordinates fail, okay? So usually when we're looking at limits, we're looking at places where domain errors occur. So where domain errors happen. Okay, where domain errors happen, and that would be like where we have vertical asymptotes or where we have holes, basically, is where the domain errors are going to happen, okay, usually. So where domain errors occur, that's where we're interested in finding the limit, and the limit is the y-coordinate at that point. So basically, this is what it boils down to, is when we have domain errors, like in this diagram right here, we have a hole at this spot, right? Okay, so what we're interested in doing is we're finding the limit at this place, which is basically saying it doesn't have a y-coordinate there, but if it did, where would it be? That's like what the limit is saying, okay? So it doesn't have a y-coordinate at a value of 1, but if it did, the value would be 3. So the limit of this graph at 1 is 3 because that's where the y-coordinate is. It has a hole there, but if it had a y-coordinate, that value would be at 3, and that's what the limit does, okay? So the first couple problems on your homework assignment, you are going to be looking at just a table, okay? So we cannot, from this equation right here, they give us the original equation, we know that the domain poops out at 1, right? There's a domain error, and it's because we have a vertical asymptote at 1. Setting that denominator equal to 0, we cannot have a value of 1. So what we're doing is we're trying to find the limit at 1. So we plug in x's that are really close to 1. We can't plug in 1 exactly because it's going to end up giving me 0 in the denominator, and we can't have that, right? So that's why we have this question mark here. So rather than plugging 1 in, which we can't do, we plug in numbers that are really close to 1, okay? So over here they started with like 0.75, and they said, okay, let's get closer to 1. Then they do 0.9, and then they do 0.999, and then 0.999999. And what they're finding is that those y-coordinates are getting closer and closer to a value of 3. Okay, then they do the same thing on the right side of 1. So they started with 1.25, and then now they're getting closer. They're pinching it in closer. They're doing 1.1 and 1.01 and 1.0001. And the closer I get there, those numbers pinch into a value of 3. So that's where I'm saying, like, when we're finding the limit, okay, we're pinching in closer and closer and closer to 1. I cannot actually find the y-coordinate at 1, but if I could, that value would be 3, and that's what the limit is. It's limiting in on either side. It's coming in on either side, and it's figuring out what that y-coordinate would be if it did exist, okay? So what we're finding here is, it says, suppose you are asked to sketch the graph of the rational function f given by this thing. Okay, use limit notation. All right, what they will ask for you to do is they will say find the limit as x goes toward 1. We're finding the limit at 1 for x, okay, of this function, x cubed minus 1 over x minus 1. And they'll say, what is that? Okay, this is the notation that they will use. Find the limit as x goes to 1 of that function. So that's just saying, what is the y-coordinate? Again, we can't plug 1 in. We cannot physically plug 1 in here because we end up with 0 in the bottom. But if we could, what would that y-coordinate be? And so we use this table to figure it out. And those numbers that are really close to 1, we can see that the y values are approaching a value of 3. So the answer to this is 3, and that's exactly what we're looking for. Limit is saying, what is the y-coordinate if it had 1, right? Okay, this one we can see from the graph that it poops out at 3. That's what the y-coordinate would be, okay? All right, let's go down to this next one. So this is actually saying right here, the limit as x goes to 0 of this function, okay? If I try plugging 0 in, right, this is 0 plus 1, which is the square root of 1. And the square root of 1 is 1, and we would have 1 minus 1, which is 0 on the bottom. And again, that's where a domain happens. That's where it poops out, okay? We cannot have that, all right? We have something bad that occurs, okay? And we can see from the graph here that that's actually a hole that happens there, okay? So it's a hole that happens at this spot. So we cannot physically get to that spot. We cannot find the y-coordinate. But if we could, what would the y-coordinate be? It's kind of hard to see this graph right here. This is the x-axis. This is the y-axis. I don't know if you can see this very good. Here is where 1 is located at. This guy is at 2. So that hole that occurs there is at 2. And this guy's 1. This guy is negative 1. That's, I don't know, you can't see that very good from the graph, so you might have to fill that in. So you can see from the graph that it doesn't have a y-coordinate here at 0. Like the x-coordinate is 0, and I go up and I'm trying to find the y-coordinate there, but it poops out like that's where my hole is. But if it did, the y-coordinate would be at 2, okay? We can see easily from the graph that that's the case, okay? But going over to the table, we can't plug 0 in exactly, so that's a question mark. But we plug in numbers on either side of 0 that are really, really, really close to 0, like 0.01 and 0.001 and 0.00001. And looking at those numbers, we can see that they're pinching in and getting close to the value of 2. That's what the limit is approaching, okay? So given that, and given the table, and given the graph, we can look at this and say, since I've plugged the numbers in and I've looked at this, we have found that the y-coordinate is pinching in at 2. It has a hole there, but if the y-coordinate existed, that's where it would be pinching into, is a y-coordinate of 2. Okay, that's what you're finding when you're finding limits. Now, that is all fine and dandy. You have to do a table and maybe even look at the graph to figure that. Going forward in this chapter, we're going to be actually calculating this using other methods, and you won't have to use a table and graph every time, okay? So that's what we're moving toward. We're trying to find the y-coordinate. We're trying to find the limit, okay? Example 2, this is the last thing I'm going to do, and then I'm going to stop, and then you can, do whatever, okay? Finding the limit. They're going to give us the graph, and this is a piecewise function, okay? So let's kind of break down this piecewise function and look at what it says here. This is your y-axis. I don't know if you can see this very well. This is the x-coordinate of 1, x-coordinate of 2, and notice here that there's a solid dot right there, okay? X-coordinate of 3, etc., right? Okay, here is a y-coordinate of 1, a y-coordinate of 2, etc., right? Okay, so here's what happens. Our function is going along, and every single value that we're going to touch is at a y-coordinate of 1, except it's going to poop out here and it's going to go down to there, right? This is like one of those piecewise functions or holes where you have like, you're going to pay $1, $1, $1 going along here unless it's your birthday exactly, and then you pay $0. And that's why this dot is down here. And that's kind of like my example that I use when I'm doing holes, okay? So that hole is dropped down, and there it is. And we're wanting to find the limit as x approaches 2, okay? Find the limit of f of x as x approaches 2. That's this notation right here. Of this function, which is 1, 0. I'm just rewriting the function out. This is what they're asking us to do. This is the symbol version of what they're asking for up here. Okay, this is how it would be written out in symbol form. And they're just saying, what is that limit? That limit is equal to something, all right? So we're trying to figure out what the y-coordinate would be if it existed. Now, this is somewhat confusing because it actually does have a y-coordinate that exists there, right? Okay, it actually exists right here, and this y-coordinate is 2, 0. So it has a y-coordinate of 0. But the limit is not 0, okay? The limit is going to be what the y-coordinate should be, right? Going in here and going in here, the y-coordinate, everything on the left and the right of that hole tells me that that y-coordinate should be 1. That's what the limit is, okay? It's just that hole ends up being filled in here at 0, right? So if I'm trying to find actually the function value of 2, like what 2 is, he has a function value at 0. His point is actually living on 0. But the limit is 1 because everything on the left and right side of that hole is telling me that the y-coordinate should be 1. And that's what a limit does. It tells you what the y-coordinate should be. Now, this one does have a y-coordinate. It's at 0. But everything on the left and right side of that hole tells me that that value should be 1. That's what that limit is saying, okay? Everything on the left and right side tells me it should be 1, okay? I hope that is okay. I hope that makes a little bit of sense. I'm going to stop there. On your homework assignment for section 3.2, which you have, you should be able to fill in these tables using your calculator. And then you might try to take a stab at like 3 through 8 just by looking at the graph and seeing that. Like number 6 is kind of similar to what we just did, where it has that dot below and then it has here, trying to figure out what the limit is. So try to take a stab at those. 3 through 8 should not take you very long to do, so you can take a guess at it, and then maybe we'll check and see how you did tomorrow, okay? So that should give you plenty of stuff to work on for class today. I hope that made sense. I'll clarify some things tomorrow if it didn't, and that's what I'm going to give you, okay?